Assalamu alaikum everyone, this is Mohammed Sohrab and you are watching EvolveSage virtual learning. In today's session we will discuss about how to do interpretation of OLS in Eviews software. Okay, so here is the result of OLS regression. Okay, we will see how to do interpretation of this result. Okay, so first of all once we calculate OLS, here you guys will have this type of table. Okay, once you calculate OLS regression. Okay, so first row will tell us about our dependent variable, which is GDP. Okay, GDP growth rate. Okay, then second table will let us know about the method which we are using during this overall interpretation, and it is least square method. Okay, we are using least square method for regression here. Okay, and this all information is about our and then in the last it shows how many observation we have included in our data. It is 47. Okay, so now we will do in protection of most important values, which were coefficient, standard deviation, then which were coefficients, prob value, t statistic, r squared, adjusted r squared, f statistic, prob f statistic, and Durbin Watson statistic. Okay, so these are the major figures which mostly we do interpretation in our research paper. Okay, so first of all, if we see this column, here are our independent variables. Okay, so oil revenue is our independent variable, then non-oil revenue is our one of another independent variable, and then inflation rate is our independent variable. These are our independent variable. We actually want to know how these variable impact on our GDP. Okay, so GDP is taking influence, so that's why GDP is our dependent variable. Okay, so first of all, we actually whenever we do interpretation, first of all we will see prob value. Okay, why actually we see prob value? Because prob value will let us know whether our hypothesis is approved or rejected. Okay, because the hypothesis which we have wrote after reading all the LRs. Okay, after reviewing all the literature review, whatever assumption we made about our independent and dependent variable, we made some assumption. Okay, we made some estimations on the basis of LR, literature review. In literature review, we review most of the literature related to our dependent and independent variable. Okay, so once we review literature, we actually write some hypothesis. Okay, so all these assumptions are based on our literature review. Okay, we assume that our independent variable will impact on dependent variable in this way. Okay, so first of all we assume that there is positive and significant impact of oil revenue on GDP. Okay, and then our second assumption is there is positive and significant impact of non-oil revenue on GDP. Then our third assumption is there is positive and significant impact of inflation on GDP. All these are the assumption. Okay, it is not necessary that our result will be as per these assumption. We wrote these assumptions on the basis of literature review. Okay guys, there are two types of directions of our hypothesis. One is that one describe the positive and negative direction. Okay, one is directional hypothesis. Okay, then second is non-directional hypothesis. There are two types of hypothesis. One is directional mean positive, which describe the positive and negative impact. Okay, so directional hypothesis describe the positive or negative impact of independent on dependent variable. Okay, then non-directional describe the significant or insignificant impact. Okay, so here we assume that there is significant impact. This we actually describing the non-directional impact of our independent variable on dependent variable. Okay, so what we got here, we got that there are two types of directions. Uh, one is directional hypothesis. Okay, there are two types of hypothesis. One is directional hypothesis, then second is non-directional hypothesis. Directional hypothesis actually describe the positive or negative impact. Okay, and then non-directional describe the significant and non-significant impact. Okay, so we wrote these assumptions on the basis of LR. Now we have performed our data. Okay, now we have performed we have calculated, or we have performed some calculations on the basis of our data, our observed data, and on the basis of our observed data, these are the results. Now we will see that whether these hypotheses are accepted or rejected. Okay, we seen that there is positive and significant impact of oil revenue on GDP. So here prob value will let us know, prob value and coefficient will let us know whether there is positive and significant impact of oil revenue is on GDP or not. Okay, so how we will see that that whether there is positive, whether there is significant impact of oil revenue on GDP or not. For that we see prob value. Okay, if prob value is less than, if prob value is less than, prob value is less than 5%, 5% means 0.05. Okay, if prob value is less than 0.05, then we will say that there is positive, sorry, there is significant impact of this variable on GDP. Okay, there is positive impact of oil revenue on GDP. So here prob value is more than 0.05, so we can say that there is insignificant impact of oil revenue on GDP. So first our hypothesis has been rejected, because our first hypothesis said that there is significant impact of oil revenue on GDP. So here there is insignificant impact. Why? Because prob value is more than 0.05. Okay, so there is insignificant impact of oil revenue on GDP. Okay, then now we will see directional hypothesis. Okay, first of all we have seen non-directional, now we will see directional hypothesis. For directional hypothesis we will see the coefficient. Okay, so if coefficient is positive, okay, if the sign of coefficient is positive, then we will say that there is positive impact of this variable on GDP. So here this variable has positive plus sign. Okay, since this variable has plus sign or positive sign, we can say that there is positive. Okay guys, so here on the basis of this sign we will determine the positivity or negative impact. Okay, positive impact or negative impact. So here the sign is positive, so we will say that there is positive impact of oil revenue on GDP. Okay, let's discuss the second variable, which is non-oil revenue. First of all we will see the prob value. Again, prob value is more than 0.05. Okay, because it is 0.08, that means it is more than 0.05. We again said that there is insignificant impact of non-oil revenue on GDP. Okay, now we will see the coefficient. Coefficient is negative. Okay, coefficient is negative, that means there is negative impact of, there is negative impact of non-oil revenue on GDP. Okay, so we can do interpretation in this way, that there is insignificant and negative impact of oil revenue on GDP. Okay, so the last variable is inflation rate. Okay, how we will do interpretation of inflation rate, let's discuss it. So first of all we will see prob value. Okay, so prob value is, so prob value here is uh, more than 0.05, so we can say it again that there is insignificant impact of inflation on GDP. Okay, so now we will see the direction. Okay, for direction we will see coefficient, so coefficient will determine the direction of the hypothesis. Okay, so as per this result, there is positive impact of inflation rate on GDP. Okay, so this is how we do interpretation. Now we will write it in a statement form. Okay, we will write it in a equation form. How we can write it in a equation form? So again, one another important test is t statistic. Okay, if t statistic value is more than 3, okay, if t statistic value is more than 3, then we can say that uh, there is significant impact of there is significant impact of independent variable on dependent variables. Again here, our t statistic values are less than 3, so we can say there is negative impact. Okay, if these values were more than 3, then impact will be significant, and it will be always as prob value is. Okay, if prob value is insignificant, then these t statistic will also represent insignificant impact. Okay guys, how we can write it in the form of equation? We will see that how we can write it in the form of equation. Okay, so what actually this 0.016 mean, and what does this 6.43 mean? Okay, how we can do interpretation of this 6.43 and 8 minus 8.38, then this 0.20. Okay, now how we can determine and how we can do interpretation of this coefficient figures. Okay, so first figure is 6.43. What does this 6.43 mean? This means that if we if we increase if we increase oil revenue with 1%, yeah, 1 unit. Okay, if we increase oil revenue with 1% or 1 unit, it will increase GDP by 6.43%. Okay, okay, we can say that if we increase oil revenue by 1 unit, it will increase GDP by 6.43 unit. Okay, again, how we can do interpretation for non-oil revenue? For that we will say that if we increase non-oil revenue by 1%, it will decrease GDP by 8.38%. Or if we increase oil revenue by 1%, it will decrease our GDP by 8.38. Okay, so there is negative impact of non-oil revenue on GDP. Okay, and how we can do interpretation of inflation, how we can describe it? uh, if we increase inflation rate by 0.2, if we increase inflation rate by 1%, it will increase our GDP by 0.20%. Okay, so this is how we do interpretation of these analysis. Okay, and on the basis of these, now we will accept or reject these hypotheses. Okay, and we will write new hypothesis as per our results. Okay, as per our conclusion, as per our results which we have calculated. Okay, okay guys, now we will talk about R square. Okay, what does actually R square determine? R square actually determine that what actually R square explain? R square actually explain that how much your dependent variable is determined by your independent variable. Okay, and we can say that how much your dependent variable is explained by your independent variable which you have choose for your study. Okay, so often most of the cases, uh, most of the research paper accept it should be 60% or 65%. Okay, most of the paper prefer that it should be 60 or 65%. Okay, so uh, I'm telling it again that R square or adjusted R square actually determine that how much your dependent variable is explained by your independent variables. That means whether you have choose correct independent variable or not. Okay, for your study. Okay, so here it is 0.12 mean that just your chosen variable determine your R square just 12%. Okay, remaining 88% are determined by other variables which you have not choose for your study. Okay, that mean if you work on these in for example, if you are working on a problem. Okay, and your problem is GDP. Okay, now you are looking for some solutions. Okay, now you are looking for some variables, some solutions, some variables which impact on GDP, which can improve your GDP, and you choose these variable for correcting your GDP, for increasing your GDP. Then these variables are insufficient to to improve your GDP. Why? Because these variables just explain 12% of the GDP. Okay, these variables determine just 12% of your GDP. The rest of 88% are determined by other variables which you have not choose for your study. That mean you have insufficient variables to work on it. Okay, if you work on these variables you can just improve your GDP just 12%. Okay, rest 88% variables are impacting on your GDP. You have to work on those variables because these variables are impacting very least. It should be at least 60%. You should have such variables in your study which determine your GDP at least 60%. Okay, if it is more than 60%, that means you have choose very valuable independent variables. Okay, which explain your GDP, which explain your problem very well. If you work on those variables, then those variables can help you more to improve or to solve your problem. But here if you work on these variables, these variables can help you just 12%. Okay, then we have adjusted R square. Okay, it is almost similar what R square explained, but here in adjusted R square we actually reduce the biasness. Okay, the biasness which exists in your data, you actually reduce that biasness. Okay, once you deduct that biasness from R square, then the remaining figure is called as your adjusted R square. Okay, so your adjusted R square is more accurately determine your dependent variable. Okay, your adjusted R square figures are more explanatory to your GDP. Okay, if we compare it with R square. Okay, because we have reduced the biasness from our data. After reduction of biasness, now your chosen variable determine your dependent variable only 6%. 0.06 means only 6% determined by your chosen variables. Now if we want to see if we want to see how much biasness is here in this data, we will just deduct 0.06 from 0.12, okay, and then that calculated figure will be called as the result of biasness, okay. That figure will be the will actually impact on your accuracy level. Okay guys, another very essential result which you have to explain in your paper is Popf statistic. Popf statistic is actually determine the overall model of your research, whether your model is significant or not for this study, okay. If your Popf statistic is less than 0.05 or less than or equal to 0.05, then we said that your overall model is significant, okay. So here in this case it is more than 0.05, so here this model is not significant. Why? Because we have seen that all of the independent variable has insignificant impact on our dependent variable. That's why our model has also insignificant, okay. If these figures are significant, then most of the chances were that this Popf statistic will also significant, okay. So here in this case it is 0.12, that means it is more than 0.05, so our model is insignificant, okay. Oh guys, now we will discuss Durbin-Watson statistic, okay. Durbin-Watson actually tell us about the autocorrelation, whether there is autocorrelation exists in our data or not, okay. Autocorrelation is very useful analysis. Autocorrelation is very useful technical analysis which actually uh, concern with the trend in the data, okay, whether there is trend in the data or not, okay. Like if whether your data is whether there is change in your data over the period of time or not. If there is no change, it remains similar throughout the period, then there will be autocorrelation exist in your data, okay. So in order to avoid or in order to overcome that autocorrelation, you can convert your data into percentage, okay. So if we see the stock exchange data, it is almost similar day to day, okay. There is very least change we can observe throughout the days, okay. So there is more chances that there will be autocorrelation exist in that calculation. Why? Because data is almost similar to one day to another day, okay. So in order to avoid it, we can use percentage, we can convert the data into percentage, because percentage will determine real size of your change in your data, okay. So if Durbin-Watson statistic is below 1.6, then we will say that there is positive autocorrelation exist in your data, okay. If Durbin-Watson or autocorrelation is less than 1.6, then there will be a positive autocorrelation exist in your data, okay. If your Durbin-Watson statistic is more than 2.4, then there will be negative autocorrelation exist in your data. If your results are between 1.6 to 2.4, then there will be no correlation exist, autocorrelation exist in your data. So always keep it in your mind that this is a very critical statistic which mostly uh, explain your results, whether they are accurately conducted or not. Oh yes, another very important test which we perform during our analysis is VIF test. Okay, what actually VIF test tell us? Test tell us that whether there is multicollinearity exist in our data or not. Okay, multicollinearity actually explain that whether your independent variables are impacting each other or not. Multicollinearity actually explain that whether your independent variables are impacting on each other or not. Okay, uh, whether there is a relationship exists between your independent variables or not. Okay, if your independent variables are impacting on each other, then there will be very least impact on your dependent variable. Why? Because they are impacting each other and they are not influencing on your dependent variable. So that's why there should be very least impact or relationship among your independent variables. Okay, so how we can check it, and how will we know that there is a relationship among our independent variables or not? For that we actually check VIF, variance inflation factor, actually determine whether there is a multicollinearity exists in your data or not. Okay, if VIF is less than 10, then we will say that there is no multicollinearity exists in your data. That means your independent variables are not impacting each other. There is no relationship exist between your independent variables and they are actually impacting on your dependent variable, which should be impact on your dependent variable. Okay, so here another test which we actually perform in Eviews is VIF test. Okay, so VIF should be less than 10. If it is less than 10, then there is no multicollinearity exist. Then there is no multicollinearity exist in your data. Okay, so you have to perform this test as well before jumping to interpretation or before writing your results. If it is exist, then you have to remove it. Okay, by adding further variables and other techniques you can use it to avoid the multicollinearity. Okay guys, this was from today video, and in next video we will discuss it in more detail and we will discuss further tests which are essential for us to perform before writing our results. Take care. Allah Hafiz.